All right, dear learners, I welcome you to this lesson 5. Yes, don't forget to inform your friends about this YouTube channel. Yes, Hyper Academic channel. Subscribe and learn. You understand? Yes. So this is lesson 5, and this lesson 5 is going to start with a question. And what is that question? This question normally carries 4 marks. Yes, question. We are going to have a question. Yes, what is this question? The question involves explaining. All right. Explain why solid lead to. Yes, explain why solid lead to bromide. Explain why solid lead to bromide does not conduct electricity or does not conduct electric current. Explain why solid lead to bromide does not conduct electricity yet and explain why solid lead to bromide does not conduct electricity and molten lead to bromide and molten lead to bromide conducts and molten lead to bromide conducts electricity or electric current. Right. Yes, there we go. Right. Remember, we have already explained why solid ionic compounds lead to bromide is an example of the ionic compounds. Lead is a metal, and then bromine, which is a halogen, group 7 element. When it gains the electrons, it forms the bromide ion. You understand? So a negatively charged ion. So lead to bromide is an example of an ionic compound. Suppose you found this question somewhere and then they were telling you that this question carries 4 marks. What would you write there? What would you write there? All right? Yes, or I think we can have an answer for it. But I think you have tried to state what you would write, isn't it? Yes, so remember, we said that in solid ionic compounds, the conducting particles are held together by the conducting particles, which are the ions, are held together by what? Do you remember? Yes, by the strong electrostatic forces of attraction. Hence, fixed and immobile. Yes, now, when they talk about molten, that clearly means that now the ionic compound was heated. But if they had said, now lead to bromide is an insoluble salt. Assuming they used a soluble salt, maybe copper 2 sulfate, and maybe they said, explain why solid copper 2 sulfate does not conduct electricity, and the copper 2 sulfate solution. Okay, that thing is very important. You have to understand what is the question talking about. Is the question talking about molten ionic compounds or aqueous ionic compounds? All right, dear children, we are answering this question. But when it comes to that part of the molten lead to bromide, there we shall say heating, because they're talking about molten lead to bromide. If it was copper 2 sulfate solution, there we would say dissolving in. You are going to see the point where that one comes in. So our answer will be that in solid lead to bromide, in solid lead to bromide, in the solid lead to bromide, the conducting particles, you specify them, lead to ions, and bromide ions, because you will agree with me that if lead to bromide is to ionize after being heated to become molten. Yes, molten ionic compounds, they use the set symbol of L. The aqueous ones, those ones that are dissolved in water, they use aqueous. So now this liquid lead to bromide. Of course, molten, when it ionizes, it gives us lead to ions. We shall use L because this is molten. But if it was a solution, then we would use aqueous. So plus 2 bromide what? Plus 2 bromide ions. So now the lead to bromide, the lead to ions and the bromide ions are the conducting what? Are the conducting particles. So in solid lead to bromide, the conducting particles, lead to ions and the bromide ions are held together by strong electrostatic forces of attraction, hence fixed, as in the conducting particles are fixed and they are immobile, hence fixed and immobile, full stop. So we have explained the other part of why solid lead to bromide does not conduct electricity. Now we are moving to explaining this one of why the molten lead to bromide conducts. So after the full stop, we shall continue and say heating. This is the point I was talking about. Heating. If they talked about copper to sulfate solution or a solution here, you would say dissolving in water. Is that okay? But since we are talking about molten lead to bromide, this lead to bromide to become molten, it was a result of being heated. So we are now saying that heating breaks the stronger electrostatic heating breaks the strong electrostatic forces of attraction, setting the ions, which are the conducting particles, setting the ions free. Is that okay? Now, when the ions become free, okay, we have clearly said that heating breaks the strong electrostatic forces of attraction, setting the ions free, and they become mobile, and they become, now the ions become what? And they become mobile, thus enabling the molten lead to bromide, to conduct. They said conduct what? Conduct electricity. To conduct electricity. Electricity. What else do you need from here? Nothing. Is that okay? So you have to clearly communicate that in the solid state, the conducting particles, you specify them are held together. You have to bring the forces of attraction. Is that okay? Yes, so because of the presence of those forces of attraction, our conducting particles are fixed and immobile, meaning that they are not free and they cannot move. Now, heating, you have to bring that point out. Heating breaks. I have said that if here they use an aqueous solution, you have to say dissolving in water. You bring it at this point, okay? Dissolving in water breaks the stronger electrostatic forces of attraction, setting the ions free, and they become mobile, thus enabling the molten. If they use the aqueous there, then you say enabling the copper to sulfate solution to conduct electricity. In order for us to discuss this electrolysis very well, you have to understand this point very well. You have to know that it is the ions which are free and mobile that enable the molten ionic compounds or the aqueous solutions of these ionic compounds to conduct electric current. Is that okay? Yes. So now, dear learners, as we come to the end of lesson 5, why don't we look at some examples of electrolytes? Now, one thing you have to understand is that after these ionic compounds becoming molten, that is by heating, or after forming aqueous solutions, that is after dissolving in water, okay, they become electrolyte. So we shall understand what an electrolyte more, but it starts with this. Alright, so examples of electrolytes. Examples of electrolytes. 1. Sodium. Let us start with what we discussed. Sodium chloride. When you say sodium chloride, that is wrong, because you are not telling us whether this sodium chloride is a solid or a solution, but you have to say sodium chloride solution. Okay, or molten sodium chloride, that will still be correct. We can have another example, molten lead to bromide. Yes, and very many others, okay, as we shall discuss them when it comes to the discussion of the types of electrolytes. Okay, yes, now you can include aqueous solutions of all the ionic compounds. Is that okay? Yes. If you write all of them here, they will all be correct. Or when you talk about the molten ionic compounds, they will all be correct here. And looking at the examples of electrolytes, dear learners, brings us to the end of lesson 5. I want you to thank you for your time. Continue encouraging your friends to come and subscribe, and they learn with us. My name is Matthias Tuafu, and thank you for viewing. Let's meet in lesson 6.